Hello, Professor Sargent here with you again. This is something I've been wanting to take a look at for a while. Let's talk about looking at a math problem and exploring that problem and forming a conjecture. Here's the problem that we're going to take a look at. First, we need to investigate a misconception. Since we are looking at something written symbolically, there's a common mistake that comes up. We're going to address that and in a similar fashion, come up with the conjecture about how the sizes of these compare. The misconception is that we could take the square root of the sum. We know, for example, that if x is non-negative, then the square root of x squared would be x. So could we take the square root of the sum of 1 plus x squared and split that up across the addition to get 1 plus x? The answer to that is no. Let's see. We're going to put in some things for x here. I'm going to make column 1 be about x, column 2 be about what we really need, the square root of 1 plus x squared, and compare that against 1 plus x. There we go. All right, and let's put in some values for x. And we want the square root of 1 plus x squared, where it would, according to the order of operations, do the squaring first, then add 1, and then take the square root. Filling that down. All right. Versus simply looking at 1 plus x. Every single one of those has come up differently. Even if you could find some values of x where they're the same, the fact that there are so many that they are not, this is not something that can be done in general. So let's look at the question again. I'm going to do something similar with using Excel to put in values for x and y and investigate this. Let's keep the first column about x, the second about y, and then the third column will be about the square root of 1 plus x squared plus the square root of 1 plus y squared. And the last column will be about the square root of 4 plus the square of the x plus y. So let's put in some things for x and y. And let's do the same for the y's. Okay, so we want square root of 1 plus x squared plus square root of 1 plus y squared. And we get that. Whereas in the last column, we want 4 plus the square of the x and the y. And let's fill these down. Well, that's weird, given what I just told you, that we cannot take the square root of all of 1 plus x squared and get 1 plus x. What's going on here? It's almost as if we have 1 plus x plus 1 plus y, which is 2 plus x plus y, would equal Taking the square root of the 4, there's your 2. Taking the square root of the x plus y squared, there's your x plus y, and getting the same thing. What happened? Well, notice that I put in the same values for x and y. So let's clear that out and be a little more careful. How about we put in things like y growing by 1/10 instead of growing by 1? So 0, 0.1, 0.2, 0.3, and so on. Okay, so now square roots of 1 plus x squared plus square root of 1 plus y squared. And then square roots of 4 plus squaring the sum of x plus y. This may not always be true, but it would seem that what we have for the sum of the two individual square roots versus the single square root, that the one on the left is always larger. In other words, the difference should be positive. And it looks like it is for all of those. Could I have perhaps missed something, though? I've only looked at a handful of examples and only put in certain types of numbers. But for right now, the conjecture is, we did see when I put in the same things for x and y that what's on the left here could be equal. Then in my second set, what I put in was making what's on the left greater than. So the conjecture is that they are greater than or equal to. So what's going on here? Why is this true? How can we show this? That's coming up next.